Hello. Dzień dobry. How are you? How's the conference? Good? Not good? I can hardly see you because of the lights. Sorry. Again. How's the conference? Good. Very nice. Now, yeah, this is a kind of feedback I appreciate. Yes. Hello. Welcome to this session. I guess we shall start. It took me a little bit longer to set up than usual because this talk is going to be a little bit different than the other ones I gave so far. Apologies if today I'm a little less energetic than usual. Last night wasn't the best night, so to say. Still, you see me wearing this lab coat because we're going to do an experiment. And, you know, it's like health and safety protocol and whatnot, right? So that's why, I'm taking these precautions to be on the safer side of things. Yes, welcome to this session. Integration tests are needed and simple. GeeCON, very nice conference, very nice lunch. Yeah, here we go. Briefly about me. In Poland, you know that my name is like a regular Polish name, right? Piotr Przybył. If you need to follow me on social media, please do. Yeah, and I oopsies, this is like old slide, so I missed that. I'm no longer working as software engineering, I'm working as a solution engineering. Basically, I'm trying to help people to run their tests better, faster, right? I sometimes also work as a trainer. So, usually from Monday till Friday, I work for this American startup called, sorry, not American, just startup, called Atomic Jar. Some call us the Testcontainers company, right? And every now and then I put some blog posts on my personal page, softwaregarden.dev. Okay, so this is me, right, when I'm on holiday. When the pandemic allows holidays, Java is always like somewhere behind me. I started doing Java in when it was 1.3, and I've been doing not only Java but also like a bit of Scala, some PHP, of course, who wasn't at the university times, Go and whatnot. So the question is, who are you? Who's doing Java? Okay, who's doing other JVM languages? All right, non-JVM languages. Okay, people, what do you do? Shout out. Scala. Okay, Scala, Groovy. Okay, like C# people, .NET people, Python people. Anyone Rusty? No Rusties, as far as I can tell. Okay, so now I guess we know who you are. Now who you can be. We have like a few positions open at Atomic Jar. If you fancy to change your job, this is who you can be. Contact either Sydney or myself. And for this session, if you have like questions or ratings or whatnot, please open slido.com, hashtag GeeCON or GeeCON, as some people mispronounce it, and select room number 1. Yes, we're going to do like a little story. You might have a granny, or another person who you love a lot, and this person is not like technical person, right? I'm the slides now, right? Look at me. And this person, let's say it's your grandma, right? She asks you, my grandchild, my beloved grandchild, I'm getting old, right? And my senses are not as good as they used to be. And also I passed this COVID, so this nasty thing impacted my smelling. So I'm not quite sure if my old gas stove I have in the kitchen is still working properly. Maybe it's leaking some gas, right? And could you please do something like get me a device that would help me, keep me safe, right? Detect this gas leaks should there be any, right? And then what do you do as a respected software developer, right? You have two options. You can just go to a market or order something online, and they will ship you a device, right, like a gas detector. Or you can go for option B, right? You can build one yourself. And I guess most of us, by default, want to go for the second option, simply because we can build something way after the deadline, but at least it's more expensive, right? So this is what we're going to do today. I am going to build with you a gas detector, right? So if you have a gas detector, let's say it's going to need some casing, right? So I have this lovely case. Let me make this bigger, right, so we can see better. Can you see it all right? Yes. So we're going to build like a gas detector in this lovely case, right? Then what do we need to start with, right? We need some power, I guess. So I hope I have this very nice power supply, right? And now I need to test this part, if it's really providing proper power. So then let me use this fan, right? This is a fan. And let's see if this fan works. And then, oh yeah, it's spinning, right? Lovely breeze. Then it means we have a proper power supply. And we don't need this thing, right? I just needed it to test my power supply. That's what I needed. So we have power, right? Okay. The next thing that we need might be like this sensor, right? That actually detects the gas particles, right? And I just happened to know a vendor, and they sold me this very nice clicky, right? Piece of equipment that's certified and guaranteed to detect gas particles. So let's throw it into our box, right? I mean, it's certified, so I don't have to test it, right? It's in there. Okay, then what else do we need? I guess we might need, like, some kind of like bars or speakers, something that would go loud, like beep, beep, in case the gas is detected, right? So maybe I have this very nice, like, speaker, right? Maybe I can just use it. Let's see if it works. Apparently it does. It's also been tested, right? So it's tested. And now, what else are we missing? We're missing some flashing lights, right? So let me toss some flashing lights. Do this thing work? Does it work? No, it doesn't. Let's perform some more unit testing. Oh, yeah. It flashes now. See? It flashes. Very nice. So now we put it here. And also what we definitely need, right, is some wiring. I mean, wiring is always good, right? So we toss some wires here. And so I think we should have every part that's required. So let's seal this box. Oopsies. Right? It's unstable version, right? And then, see, it flashes. It flashes, right? And we have various parts in this box, right? These parts have been tested. Every part has been tested, right? Now, my question is, who's willing to install this device in your granny's kitchen? Yeah, we have 3 maniacs in the audience, right? And the rest of you, why aren't you eager to install it at your granny's or your mommy's kitchen, right? Look, it's very nice. We've tested every part. Okay, it even has this very nice smileys, right? See, it's very nice. It's user friendly. Huh? It's really easy to operate. It still flashes. So what's preventing you from using it? Or maybe apparently it's not such a good thing, right? Maybe we know as software developers that okay, like all the parts have been tested, but maybe we kind of like suspect this is not something we want to use, right? And now my question is this. How is this box different from the systems we build every day? That's the point, right? We test the parts like crazy because we've been told that unit testing and whatnot, we test all the units, and then we assemble it, and oops, it doesn't work, right? So would you install it at your granny's kitchen? I guess not. So what else can we do, right? We can fall back to the previous solution I said, and maybe we can like get like a working component or like a pre-assembled thing and see if it works, right? And then we have this gas detector, and it's not going to be like a product placement, it's just a demonstration. I don't recommend using this particular gas detector. It's just I needed something. See, so it's like connected to power source, right? It has also like some lights and like a display, like how many particles are detected and whatnot. And now, question is, let me see if the cam gets that. No, it's too bright. How do we test the thing? I don't know if you can see it. It's written here. It has a little button, and it's written here, push to test, right? So I can push it, and let's test it. Very nice. Oh, stop. Enough testing. Build has passed. It has like the build is green. I don't know. You see the green light, right? So the build is green, everything. Now, We may say our testing is done because we just tested it. Now let me ask you this very question. Let's imagine this situation, like this Gedanken experiment. We have this thing, your granny is sleeping, and the gas is leaking. Do you think that the gas would be kind enough to just, oh, let's not disturb the lady? Like, on the lady's behalf, I'm going gently go to the kitchen, right, and press the down button so the alarm sounds. This is not usually how the gas behaves, right? So just by pressing this button, we emulate or simulate that the gas is detected. But still, we don't have the guarantee that the gas is properly detected. So how do we test it, like for real, right? We have to put this thing into like a box, into a container, like this, right? So we have this lovely container, right? And we're building this alarm detector in this box, right, full of surprises. And the last thing we need is Chad. If you don't speak Polish, Chad in Polish is for carbon monoxide. That's the thing. So we need Chad, right? So what I'm going to do now, I'm going to seal the system that we're testing inside a box, right? We seal it. We make sure the gas doesn't poison us. We can even apply some extra safety measures, like another layer of isolation, because why not? And now let me open this little tiny hole. And now, come on, we should be able to intoxicate the atmosphere inside and see if this gas detector works or not. Usually it does, but let's keep our fingers, cross your fingers, folks, and let's see if it works today or not. And now let's wait a second or two. Shaky, shaky. See, maybe the demo gods aren't with me today. Let's intoxicate the atmosphere even more. That's how we see the tests are important. See, I say the test is successful, right? Now let me turn this off. Turn this thing off because it's too loud and so on. So by this approach, right, we have, I hope, I demonstrated that, successfully performed integration test, or maybe even an end-to-end test of this thing we bought. And now, my question is, which device would you install at your granny's house? This thing or this thing? We performed tons of unit tests in here, right? We tested every part. But do we have enough confidence or as much confidence by performing a single integration test like here? Who would use this thing? And who would use this thing? Again, see, I saw a lot of hands here. And even Cuba stopped voting for this. Very nice. I mean, you're getting something out of this talk. I like it. So my question is, why do we keep testing our systems like this and not like this? If a single test like this gives us more confidence, right? And that's the whole point of this presentation. So I hope I convinced you, or at least demonstrated, that integration tests are needed, right? Integration tests are needed, so now let's see if they can also be simple. Let me take off the gloves. I hope they won't be needing them anymore. All right, so for the simplicity part, I'm going to use, surprise, surprise, Testcontainers, right? It's a family of libraries that allow you to create your integration tests easier, right? So you don't have to provide the dependencies on your own. It's just everything, the whole infrastructure is done in the code. And the reason I said there's a family of libraries is this, right? It's not only Java. I mean, the Java is kind of the most sophisticated one, the oldest, the one, which has the greatest number of features, right? So it's this thing, but there are also Go, .NET, Python, Node, Rust, and I know there are also other ones, like Scala, for example, right? Yeah, and if you need to learn something more about test containers after this talk. If you're greedy, like you really like the idea of having the confidence to deploy something on Friday evening, even being intoxicated yourself, then you go for testcontainers.org and you start from there, right? Slack channel modules, whatnot. And how Test Containers does it in general. There is no magic. There is no secret ingredient, right? It's using containers, just as I use the container to test the thing, right? Test Containers, as also the name implies, is using containers. And the containers are, I mean, the whole set of libraries is standing on the shoulders of a giant, and this giant is called Docker, right? So the whole thing is, instead of having, like, you know, all these YAML files. I mean, Bruno is not with us today, I guess, but some people say that YAML means yelling at my laptop and whatnot. I mean, who loves YAML? Okay, who loves YAML and is not a troll? Yeah, okay, just 3 hands left, right? So we have devoted YAML lovers. But for everybody else, if you just want something to bring your dependencies without YAML for a test and clean after, right? And should that be Java or Go or .NET or whatnot, you can go and use test containers. That's the whole point, right? And what I'm going to do now in the second part of this presentation is let's try to build a software that sort of like loosely works in a similar fashion to this gas detector. And mind you, this is for demo only, right? We are not building like a proper software that should be deployed on such a hardware or anything like this. I mean, this is demo only, okay? And we're going to build a carbon monoxide detector, right? And test it. That's important. Not only just build, but also test it, which starts in less than 4 seconds. That's, let's say, our business requirement, and checks registered particles every second, and raises an alarm when there are more than 400 particles per million detected. And okay, that's maybe that's for later. All right, let me close this. We shouldn't be needing this anymore. Yes. Okay, let me go for this other thing. Now, do you see it all right, or shall I go into this presentation mode? It's all right? It's okay, cool. Right, so see, I'm building a detector, and this detector should have this alarm level, and this translates into this 400 particles per million, right? And here we're going to register how many particles we detected, right? And any other particles, and we're gonna use HTTP server. The architecture behind this whole solution is this. This detector is operating HTTP server, right? And we are sending requests, and each request represents a single particle, and we try to determine what kind of particle that is, carbon monoxide or something else, I don't know, oxygen, nitrogen, whatever, right? And it starts, right, so it prints us in this kind of like logFMT format, similar-ish, I would say, that it started. Here we pass that on which port it should start operating or listen to these requests, right? And yeah, we start this, create this detector, we start operating, and then we basically output to the log it started, right? And how the detector works, we open a socket on this port, right? And whatever we, like this thing may be easier. Basically, if we have like someone sends us a GET request, it can tell us like how many particles it detected. But beside that, it also can capture particles, right? And in capturing is really simple. We get like the post requests, and we read the whole payload and try to see what kind of particle that was. If you're not familiar with the syntax, I mean, this is how new Java looks like. I mean, I did that in GeeCON Prague. If you're interested, the video is there. Right, and yeah, and we write some response as well sometimes, and we set executor, because what we also do here is that we perform this check. Like every second, we are checking for these particles. Right here, we see we perform the check, and initially we're going to sleep for 3 seconds. I mean, don't do that at home. Okay, this is demo only. In production code, you don't want to sleep, but I'm just building something to show up, right? And this is how we perform this check. Oh, it's here, right? So every every time we check for the carbon monoxide, we just write checking, right? And then we get the number of detected CO particles and other particles. And if we divide these things and it's above the alarm level, we are going to raise the alarm, right? So this is like also, I don't have any other dependency, like we don't signal it on Kafka or we don't send email or didn't do anything else. We simply write in big letters alarm, right? And that's it. We can also like prepare the report for the GET requests if we're interested. And this, you see the whole capturing of the particle. Not a big deal, right? This is how it works. Right, so how to test this thing? And there's a very important shortcut in IntelliJ IDEA, which is the IDE I'm using. And on Linux, it's Control-Shift-T. And it takes me to the test, or if I don't have any tests, I'm creating a new one, right? But oopsies, I have some tests predefined to make this session simpler and faster, righty, but remember this Control-Shift-T. All right, so how do we test this whole thing, or how kind of like one of the ways we can test this, this detector? We're gonna use Testcontainers, right? We build this software, we build the jar file, and we're going to deploy it in a container, right? And then we're going to test it in isolation, like intoxicate, for example, its atmosphere and whatnot. So I'm, Maven drill, it creates me the artifact in target, right? And I'm basically, I will use this jar to put it into container. And how do you create the most generic container that's absolutely the cornerstone of the whole Testcontainers philosophy? We create new container, right? And we tell it like what Docker images it should use. And in this example, I'm going to use the latest GA Java, right? Java 20. However, you can use any other image should you need for anything else, right? As long as there's a Docker image, it will work. And you can also use like your private repositories or other repositories, it will also work. And what we're going to do is we're going to copy a file to this container. So I'm going to copy this jar file I produced, right? And put it into tmp-detector.jar, right? And then I'm going to expose a port outside, and I chose to expose port 7890 because this is the port I'm telling my detector to use for its operation, right? So that's the whole thing. And then I'm going to run the command Java, and because I'm using preview features, right? And because this is not like a non-premises production code, then I'm going to say jar and run this whole thing. So this is how I can, in the most basic way, create a container using Testcontainers. Okay, and then I have the first test. It's for now it's disabled, right? But we'll start running it. And the first requirement that we had was, okay, so hopefully we are building a CO detector. I'm going to test it. And the first thing was it has to start in less than 4 seconds, right? So we are going to create this container in this try with resources, right? Because we want to take control of this container manually, keep it in our hands. Containers are auto-closable, and as you should know from Java 7, if the thing is like used inside this try with resources, it will be closed when I exit this part. I mean, exceptions or not, right? If you don't, I mean, there are ways like to integrate with JUnit framework. There are you can start these containers as fields, and that's maybe even like recommended way. But this is like the most basic way. And if you forget to stop the container, there's a thing called in Testcontainers called the hook that will clean after us. We'll get to that. Okay, so I've created this container. I'm starting it manually, and now what I'm going to do is I'm going to access the logs of this container, right, and split them into lines, and then I'm going to filter out everything else except the lines that start with start, no pun intended, and then I'm going to kind of like pass them into events using this log fmtish format I have, right? And then I'm going to assert that the events contain starting and started, because it should also write started, right? Starting and started. So this is how I assume the thing has started, right? And that also like started checking, right? There's at least one like entry in this whole logs saying checking. And what I'm going how I'm going to enforce this 4 seconds, right? So I'm going to get the event, that's why I pass them here, or for starting. And so the started thing should occur, not later than 4 seconds after, right? So that's why I then check the timestamp of the started and ensure it's before or at least not later than the started deadline, because this is the deadline. All right, and now let me run this code in this test in like a CI-ish fashion, right? And see if it works. First, I'm building the artifact, and then I'm running a test that's testing this artifact, right? Okay, now we're gonna see what's happening, how the life cycle or how the machinery under the hood works when it comes to test containers. You see. There was a system check performed by the library, because Docker should be, the Docker environment should be at least 1.6, right? And then it started to pull images. And this happens only once. If you don't have this image pulled, it will happen only once. So see, the image was pulled, right? But that was for the OpenJDK. And we were also pulling the image of Ryuk, right? And the Ryuk is this container that's also run by test containers by default. You can disable that, and it's basically, it involves like, this death letters or being like an angel of death or whatever we call it. Like when all the tests are finished, Ryuk detects that all the tests are finished basically and kills every remaining container if you didn't close it on your own, and then kills itself. Right, so it means that after the whole test, we should, let me actually check. It's not a good idea, but we are in demo. Let's see, Docker, PS. See, I have no containers running. Right, so this is how it worked. So it got pulled again, and now we're checking if this whole thing started within 4 seconds, and it says that we expected, these are the logs, right? And we expected started, but started wasn't there. So apparently, our gas detector didn't even start. Right? So what happened? Ideas. Okay, what happened is this. Let me maybe, because I'd like to show you like all the demos today. What happened is this. We are kind of like misusing test containers, right? Because by default, there was a concept in test containers known as waiting strategy. So the library needs to know when to finish this call, when to consider a container as a started, ready to operate, integrate, like respond, be a resource in your tests, right? And if we expose a port by default, the library thinks like this. If this port is opened, it means the container is ready to be used, right? And apparently, this might not be our case. And again, I'm using Control-Shift-T, meaning I'll be switching between the code, like production code and test code, right? And see how it happens. We have this detector, right? It starts operating, and it opens the port. Where does it open the port? It opens the port even here, right? It opens the port, right? When we in the constructor, right? So we open the port here. And then it starts operating, and remember the pesky sleep, it takes 3 seconds, right? And that's why in this moment of time, the library thinks it's already started, but it's not the case. So what we should do, we should apply another waiting strategy, meaning we should tell the library, you should also wait for this event in the logs, right? So let me just, how would do that? We should go with, now I'm typing from memory, waiting for, and now it should be like wait for log message, and it should be like, if I'm not mistaken, started like this, and just once. And let's see if it works now, right? Now I hope I told test containers not only wait for this port to be open, but also wait for the system that's in the container when it reports that it's ready. This is, for example, how databases operate frequently, I would say. They not just open the port like a socket, right? But also they need to tell you like database is ready, for example, to like take your commands. Let's see if this thing is working now. You see, now we don't see the images being pulled because they already pulled. And come on, work. Or maybe, gosh. 4 diseases, sorry. Shouldn't it be like this? I mean, the regular expression, tests, okay. Yes, see, that's why regular expressions are hard, right? Yeah, that I didn't plan to demonstrate it, but apparently this is how it is. And now we have our test successful. It means that now it says that our container starts within 4 seconds. I mean, the gas detector inside the container, right? And there's like it's within 4 seconds and whatnot, right? So very nice. It wasn't actually the bug in the software or the system under test. It was an issue in how we put it into a container. I mean, we had to like seal it properly and whatnot. Now, let's move to the second test, right? And the second requirement that we had was that it should check for registered particles every second. Imagine that we have in our detector has like this blinking LED, and every second it should like flash, 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 basically saying checking, 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 right? And we need to say that we need to be sure that it does it like every second, at least more or less. So again, I'm going to create the container the same fashion. I mean, you see, and then I'm starting it, right? And again, I'm going to get the log lines, right? And I'm going to filter the ones which are checking. And these are the check events that kind of like system starts before. And then what I'm going to do, I'm going to use a utility that's also coming for you with Testcontainers, right? And it says that between 3 and 4 seconds after the thing has started, I expect, that's why I'm waiting for 3 seconds, like delaying this whole poll, because there's like little sense to pull it earlier. I'm expecting that the number of these events I had here, that is size before, plus the events I've checked till now, is at least 3, meaning at least 3 seconds have passed, meaning I should have recorded at least 3 LED blinks, right? So let's run the tests again. Green, red, ideas? I can hardly see you. Okay. Nobody like wishing to tell if it's going to be red or green. Very nice. Very nice. The test didn't pass. Apparently, we're not checking every second, right? Let's see what was the message. Yeah, the expected to return true, but it was false, right? So this checking within 4 seconds didn't produce this checking, 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 right? It didn't behave like this. So what could be the reason for this? Let me cut some corners. And there's this ancient Polish saying, sorry for my French, pamiętaj cholero. Exactly, don't divide by 0, right? And let's go to this nasty bag, right? See, what's the number of all particles, right, when it starts working? 0, right? So when we try to divide something by 0, it will basically go belly up, right? And it's because this, like we use like just this executor and whatnot, it stops operating, it stops checking. So what we have to do here is we have to go and say that O equals big decimal 0. Oopsies, touchpad, sorry, and not, right? So we are not bother with checking what's the ratio if we haven't detected anything yet, right? That's why now it should be, I hope it should be working again to ampersands, right? Sorry, a little stressed because I'm on this stage and whatnot. Okay, let's run the test again. Build success. And now, okay, we run the first test if it's starting within like given time limit. I'm not picky about the test. And now it's again running. Now it's running the second test. Build success. Great success. Very nice. Okay, so there's this another thing. Let's go for the third test. Right. And the third test is, what's the requirement left? Raises alarm when CO particles reach this ratio, right? So above this ratio, I should see alarm, alarm, alarm printed, right? Because I have this thing in here. So again, we are going to create another test. It should alarm be above this ratio. Again, creating container, starting the container. Maybe it's not wise. Maybe I should just have this this container created once and started just once for the whole test suite, right? That would be better performance-wise. But this is like really like one-on-one. Okay, so what we do, we create this HTTP client. Good stuff, Java 11, right? By the way, who's using Java 8 or below? Don't be shy. Don't be shy. Okay, just a few hands. Okay, so I assume everyone else is using at least 11 or above. Very nice. So we should know it. So I'm creating this HTTP client, and then I'm going to say, like, I need to create the URI, which I'm going to use to send these particles to that thing inside the container, right? And some people would cut corners and set here, for example, like local host, because it's local host, and then for port, they would say, what was that, 790, something like this. And you shouldn't be doing this because of two reasons. First, you don't know if this container is running on your local host. Because Testcontainers is smart, and it can detect that you wired like containers running elsewhere, like in a server room, in the cloud, whatnot, right? Kubernetes cluster, whatever. And that's one thing. The other thing, this is true evil. I mean, random port is true evil because then you want to deploy another system and there's like a port clash or something. Or for example, your ISP doesn't allow you to use, the hosting company doesn't allow you to use this port because reasons, and it's hard-coded, so then it doesn't work, right? So we don't want to have hard-coded ports. That's why we here know what's the host when this container is running, right? And here we can basically get the first mapped port. And because we have just one port, it's a no-brainer, right? It's this port. If I had multiple, I would need to call the get mapped or get mapping, something like this, right? So now I know how to call or send requests to this detector running inside this container, right? And then I'm creating a dummy request for sending oxygen, carbon monoxide, and then I'm going to create virtual threads, right? If you're still not into virtual threads, you should be because they are most probably GA in this September, right? So little time is left. And we're going to send 1,000 oxygen particles and just one carbon monoxide particle. Still, it should be above the ratio, right? So when it's above the ratio, right, we stop this executor, and then we, let's say, give us at least 10 seconds for this executor to stop. It should stop immediately, but just in case, right? And then, again, we use a utility. And then we are saying that we wait for no longer than a second because we expect this thing to sound almost immediately, like 1 second tops, right? And we check the logs, and if we want to see if in these logs we have alarm, right, printed. So now let's run this test, or all the tests to be precise, and let's see how the system under test behaves. Righty, so. Starting within 4 seconds, very nice. Checking, very nice. And now we see if it really raises the alarm. It doesn't. See, should raise alarm, and we didn't see alarm in this output. So these are the logs that we got from the container. Right, and you could see it was starting, then checking, then checking, then checking. Then it was reported as started. Then it was checking because we waited this 1 second more, right? And it didn't raise the alarm. Okay, so what happened? Any ideas? I mean, I thought I have a whole room of consultants. Sorry? Requests weren't processed. We can check. Now I'm going. Let's forget about the DDD for a second. Okay, let's be pragmatic. Let's be pragmatic and let's see. Let's add this exception, right? And now I'm going to run. Let's see if it works. Let's put a breakpoint here, just to be sure, and let's run it from IDE right now. Let's see how it behaves. Fingers crossed. Oops, it didn't even stop here, and it blew before. Okay, it's sorry, of course, because I have this thing, right? So I have to comment the check, and let's use this reporting capability of the container, right? And let's debug it again. This is live, folks. That's why sometimes things don't work as expected. But let's see. Come on, move on. Okay, we are here, and we have this response, and this response body is. Let's see here, and what was the shortcut? Evaluate. Apparently, it recorded it. See, it recorded 1 carbon monoxide particle and 1,000 oxygen particles. Yet, it didn't raise an alarm. So I'm sorry, the requests were captured, right? But this is how we can see we can stop the world and examine the insides of the container, like the file system, the logs, and everything, and we can interact with the system that's running inside and whatnot. I mean, that's not a big deal, right? So let me show you what was not okay. Again, division, right? Apparently, when you use big decimal, right, and you divide an integer by an integer, right, it will produce you an integer. And what's 1 divided by 1,000 in terms of integers? It's 0. That's why it's not above the alarm level, right? So we need to tell that you have to be that much precise, at least as precise as the alarm level is, right? So I'm going to say alarm level scale, and we're setting this as a scale as explained in this Java doc. Remember, folks, be friends with this extremely lovely Spanish guy named Manuel, right? Always be friends with Manuel, and Manuel will guide you, right? So let's try to run this thing again. Let me stop this from the IDE, and let's run it the CI-ish fashion. Let me put it that way, and let's see if the test passes. I mean, the first one, the second one, and the third one. In the meantime, I'd like to tell you I brought some stickers. So if you fancy to get some Testcontainers or Atomic Jar stickers, please help yourself after the talk, right? Please don't take anything else because I need this as my speaker equipment. Yeah, see, it was quick. So the build is successful, meaning our test has proven that at least when we have this ratio, it will raise an alarm, right? As specified here, right? And so the story goes with the business requirements, and you add more tests, and you verify them, and so on, right? And there is more. There's a nice thing called Testcontainers workshop. We give it at some conferences where they have workshops or not, but you can also do it on your own, right? And as you can see, there's a lot of things we can do with Testcontainers. It integrates very nice with Spring Boot. Who's using Spring in production? Okay, very nice. Who's using Spring 3? Because you don't have Java 17, right? The rest of you. Pity. Yeah. So see, again, I'm using generic container for Redis because Redis is really simple. It's as simple as my detector when it comes to running, right? So it has this, just the image and exposing this port, right? When I need to provide like a data source for Spring, I can basically use this JDBC URL, right? And it's clever because Testcontainers integrates itself with Spring, and it registers itself as a JDBC driver for all the database prefixes that start with TC, right? So then basically it means that this part is sent to test containers, and test containers passes this part and is able to say, okay, now I need to run PostgreSQL in this version and with this database and whatnot, right? And who knows how to configure and run Kafka by heart? Like, okay, you doesn't count, Daniel, you're a freak. Anybody else? Like zookeepers and whatnot, the ports, right? Exactly. If just like me, you can't memorize the whole thing, you can go and use the thing called module, right? So we have a module for test containers for Kafka, and it will start the whole thing for you. See, it will send the brokers, zookeepers, ports, whatnot, like the environment variables for databases. It can like also initialize them and whatnot and whatnot. And there's like really many of them. Let me go back here and the testcontainers.org. Okay, and see the modules are here. There are really many of them. Okay, we have Haskell now. Oh, I need to update my slide. See, it's Haskell as well. And we have the database modules. I mean, by default, these are supported, right? Some of them are as official modules, even supported by the vendors. And then there are also like other, you see, we can go for like, I, for example, love this Toxic Proxy for intoxicating your network, right? One of my lovely ones. Elasticsearch, like whatever you need. Right, and you can also create a module on your own for your own company if you need it, and then you can try to share it with other people if you think it's worth sharing. And that's it. And the thing I was using today was Testcontainers Cloud. So I know I'm like talking a lot and I'm quite loud, but I guess you didn't hear my fans roaring, right? Because Testcontainers Cloud was used by me, and it's on desktop. It's this little agent. What it does, it basically runs all the containers I was using today in our cloud, right? So they are not running on my machine. Tests are running here, but I'm not using my resources, local resources like CPU on the RAM, or to run these heavy containers, right? I offload this to the cloud, and this is an opportunity for you, because we are in public beta, to get into free trial, free as in no credit card number required, right? And you can use it as well for desktop and for your CI environment. Some people like it, so I guess it might be good stuff, right? And we are reaching the end, so I would love you to always, and for everyone, for every speaker, share your feedback. Not just me, not just as GeeCON here, right? At every meetup conference, just share your feedback, tell the organizers, tell the speakers what was good, what wasn't good, what wasn't nice, and so on. I accept feedback in any form, right? In Katowice, I was once given this lovely paper, so any form. And once again, if you have questions or would you like rate this talk and any other talk at GeeCON, please go to slido.com, #GeeCON, and room number 1. And yes, in case you're watching this later on YouTube, or you don't want to use Slido because reasons, I don't know if there are any, you're more than welcome to use my my other feedback form, which is simple Google Forms, anonymous for me, so we can share your feedback, I don't know, hate, whatever you have. And that would be all. Thank you very much for today. If you need to follow me for more tips on Java, test containers, general IT advices, or just Pool Life advices, please do so using either Twitter or Mastodon. This is the link for the slides today, everything that was shared if you need to. And now I guess we have a minute or so to answer some questions using Slido, should there be any. There are just 2, right? Checking log, there's messages and tests. Is it the only for demo purpose, or can we do that on production-ready code? Yes, of course. I mean, the container is just like with Docker container, right? You can check the logs of the container. You can check the file system. You can, just like I did, you could copy a file, run the file, then you can copy the results back and whatnot. You can do whatever you can do with a container, right? And there's even more than this. Let me show you. When we, for example, have this generate container, then I can go and say I can go with, and there's like tons of things you can do. You can run with a command. You can send environment variables, access to host, copy files there, back again. Right? You can set it up with network and create a whole network of containers and whatnot. It's just instead of doing that in YAML, you do that in a language you like and use every day at work, right? For example, as Java here, but you could use any other that was shown, right? The other one is, what about quality over long term? Wouldn't you want to test each detector interval components independent to make sure they work correctly for a long time? Yes, of course. Just don't get me wrong. I'm not trying to say that unit tests are obsolete or the part tests are obsolete, right? For example, if you just need to test this single light, right, this thing, there is no need to assemble the whole container, intoxicate the atmosphere, and then check if it's running or not, right? So testing a single part is still useful. It optimizes the resources and whatnot, but maybe it's just that. Maybe it's optimization of this testing, not giving you the ultimate confidence to install it on like a Friday afternoon. And there's like good quote. I can't remember who said it, but someone wrote it on Twitter, like regarding mocks, for example, that you should be mocking things you control, and if there's like external dependency that you don't control, you shouldn't mock it. Then you just create a test for it, like integration test. One more question. What are the requirements? Is Docker embedded or have to install it manually? You need to provide a working Docker environment for test containers to run. And there's a number of ways you can do that. I'm on Linux machine, so I can use my own Docker, right? Or I can use Testcontainers Cloud, or then your ops people can provide any other Docker for you, right? And it should be working. And I hope that today I managed also to show you that the pyramid may be upside down these days, right? So maybe we should start with this single integration test down here to be as foundation for everything else, to give us confidence to test everything else. Because our systems these days aren't just random individual parts, but also they work as a whole, right? Because of interconnected things. So integration also matters in our tests. I think we're after time. If you'd like to talk to me, I should be available today till the end of the day, maybe also tomorrow till lunch. Thank you very much. Wash your limbs, stay healthy. Good luck.